All right, so the next section we're going to look at the unit circle. So here's kind of a visual of where we're getting some of this information that we're going to write down next from, so you can look at that, kind of reference back to it. But here we've got the unit circle is a circle with a radius of a unit 1, because the value of r is 1 for each point x and y on the circle, which is just looking at it over here. The sine, cosine, and tangent values of theta are defined as this. So here's what they're defined as. So sine of theta is y over 1, which is equal to y. So sine of theta is equal to y here for the unit circle. So if we know the y coordinate of a point, we'll know what sine of theta is. Or sine of theta will be that y coordinate. Then for cosine of theta, it is x over 1, which is equal to x. And then tangent of theta is equal to y over x. So we can get that from our point that we're given, or what we'll get for sine and cosine, like of an angle, will actually give us that point, because if you notice here, it says the coordinates for P, they can also be written as cosine of theta, because here cosine of theta is x, and it can be written as, well, cosine of theta will be the x coordinate, sine of theta will be the y coordinate. And that's because here, sine of theta is equal to y. So it's just x and y for a ordered pair. Now, special angles here that you'll need to know or remember. So you can pretty much use all of these to figure out all the rest of them. That's why these are like the popular ones. So 0, 360, 45 degrees, 60, 90, 180, 270, and 360. Those are all of the more popular ones. That's the ones that a lot of people know. But then you could actually use all of these to try to figure out all the other ones. So 0, 90, 180, and 270 are all on an axis. So those are, I don't even know how you'd say that. So it'd be in a quadrant. So I guess it'd be quadrant. I don't know. Either way, they're just like quadrant angles, because they're on those x and y axes. You don't really need to know that, but it's just some added information. So these values will be good to know. So I'm going to give you all of those. It says memorize them here. You don't necessarily have to have them memorized, since we're using our notes and stuff, but you'll need to keep up with these. Now, I have all of these written out for you, so you'll have to make sure to pause the video here, because we're going to look back at all these. So make sure you get these written down, though. So like for 0, our radians, we've got a radian, sine, cosine, tangent, and then our point. So for 0 and 360, we've got 0, 0, 1, 0, and since cosine of theta was 1 and sine of theta was 0, that gives us our point 1, 0. So then all the rest of these work very similarly. We'll reference back to this and use some of this. Now on tangent, that's where we actually have to do some of these calculations. So I did those for you here. That's just dividing there. I know it's kind of sloppy, but it's a small circle. As long as you know what tangent is for each of these, then you won't have to worry about it too much. I just gave you the math just so you could see where I was getting like the undefined places and stuff like that. Because if we're doing y over x for some of these, like sine of theta for 90 degrees is 1 and cosine is 0. So we would have 1 over 0, which is undefined. So I'll put some of those there just so you could see them. But make sure to pause the video and get this written down. I went ahead and gave you all of this just so we could save time for this video. So we'll come back to this and use it some. So that'll show you how we're going to use it. But next we need to do a little bit more labeling. So with the unit circle, we can label the ordered pairs above. We can use a reference angle to find the remaining angles. And you'll see here, we're going to get down to some of this, and we'll actually be able to figure out some of these with our reference angles. And that'll be what we do there. So this is another part of this you need to make sure you get down, just because it's going to help you. Now I'm going to give you another sheet where this it has all of this information on it. But pretty much what this is saying is, for sine, when it's in quadrant 1, it's positive. When it's in quadrant 2, it's positive. When it's in quadrant 3, it's negative. When it's in quadrant 4, it's negative. And then it has cosine and tangent as well. That's going to help you because what we'll do is we'll use some of these angles here and actually figure out the values, but then they may have to be plus or minus depending on where your what trig function you have and what quadrant it is in. So our trig functions, this is just talking about when they're positive. I'm going to let you look more at all of these, but you could, some people will teach it this way too. They remember the phrase, all students take calculus, which means in quadrant 1, all of them are positive. In quadrant 2, just sine is positive. In quadrant 3, tangent is positive. And then in quadrant 4, cosine is positive. So some people teach it that way. Some people say, all right, if you know where they're positive, then they're always like in quadrant 2, tangent and cosine are going to be negative because sine's only positive, the only one that's positive in quadrant 2. But instead of making you do all that, I just think it's easier to have this chart here and to actually give you a reference to see. So you can see here that sine's positive in 1, 2, and then it's negative in 3 and 4. And then like we talked about, cosine's positive in 1, negative in 2, negative in 3, and positive in 4. And then tangent's positive in 1, negative in quadrant 2, positive in quadrant 3, and negative in quadrant 4. So if you remember our quadrants, it works like a C. So we start off with 1 in the top right. Then quadrant 2 is the top left. Quadrant 3 is the bottom left. And then quadrant 4 is the bottom right. So those are your quadrants. Now, you'll know where they fit in because this is 0 degrees, this is 90, this is 180, and this is 270. So that'll give you an indicator. Like if it were 150, you would know that it was in quadrant 2 because it's somewhere in between 90 and 180. And like 300 would be in quadrant 4 because it's in somewhere between 270 and this would actually be 360 as well. So it would be in between 270 and 360. So that's how we're going to use those. Then depending on your trig function that you're asked to use, like quadrant 4 may tell you that sine's going to be negative or something like that. So that's how we're kind of going to go about using these. All right, so we can answer a few of these questions based upon that. So like you're going to be given some pretty straightforward ones on your homework. We're not going to worry about like secant and stuff like that because it can get confusing. We're going to keep it pretty basic. So tangent of theta, if that is greater than 0, which quadrant could the terminal side of theta lie? So if tangent is greater than 0, then what terminal side could that lie in? And it would actually be 1 and 2. So here's what you're determining. You're determining if that has to be positive, where could the terminal side of tangent lay? So if we wanted to know where tangent is positive and our angle is greater than 0, it would be here somewhere, which would be in quadrant 1, because we know that tangent's positive in quadrant 1. And then it would also be 3, because we could have a line here, a terminal side here, and it'd be positive there. So we would say it could be Q1 or Q3. So that's just saying if tangent of theta is to be positive, where would it have to be? So tangent is positive in 1 and 2. You could also look at this chart too and not even have to go look at that. You could look at this chart here and say, okay, tangent, for it to be negative or for it to be positive, it would have to be in quadrant 1 and quadrant 3. Then we could do the same thing with sine. So if we want sine to be positive, which quadrants would it have to lie in? And it would have to be in quadrant 1 and quadrant 2. Or we could go over here and say, okay, if it's greater, it would have to be here and it would have to be here. All right, so quadrant 1 or quadrant 2. So we're not going to worry about doing these problems or these problems. Those get a little, I don't know, they get a little bit too complicated with what we're trying to get through. All right, so now this leads us to, we want to find the measure of some angles. Well, we're going to find the measure of, or the exact value of these using the measure of reference angles. So we're going to have to go, it's kind of a review over reference angles. We're going to find our trig function for that reference angle, and then we'll adjust the sign if needed. So here's what that will look like. At first, it'll be a little weird, but I promise it's not too bad. So sine of 150 degrees. First thing we need to know is we don't really have, so if we go back up to our chart here, we don't really have 150 degrees here that we can go back and look at. So we want to find a reference angle that may let us use one of these for our value. So here's what we would do. If we were to draw this, 150 degrees would be somewhere in between. It would look something like this. So it would be, if we want to use a reference angle, we would use 180. So our reference angle here would be 180 minus 150, which is 30 degrees. So our reference angle for sine of 150 degrees is 30 degrees. So what we'll do is we'll go and use that and go to 30 degrees and then go to sine of 30 degrees. And that is right here. So sine of theta of 130, or sine of theta of 30 degrees is 1 over 2. So that's the value we're going to use, 1 over 2. Now we need to determine the sine. So this sine of 150, that 150 degrees would fit, we need to know what quadrant it would fit in. So I hope we could all see that it would fit in quadrant 2. So if we go back to this, it would be somewhere right here, this angle would. So it's going to fit in quadrant 2. Now in quadrant 2, sine is positive. So this is just going to be 1 over 2 as our answer. If it were like in quadrant 3, we would have made this number negative because sine in quadrant 3 is negative. So that's kind of the process we use here. We use a reference angle first, then we identify where our trig function is on like quadrant, which quadrants it's in. Or we identify the value that goes with that trig function. Then we identify which quadrant it's in and determine our sine off of that. So we'll do a few more. So let's go to number 6. So number 6, we have tangent of 300 degrees. Now, I'm going to just tell you, you're always going to compare this number to, because, well, it could be a couple different things. So you're always going to, if we have a graph here, we're going to have one of our x-axis is going to be 0 degrees or 360 degrees, and the other one's going to be 180. So when we're looking at reference angles, you're only going to have 3 choices to compare your values of your angle measure to, and those 3 choices would be 0, 360, or 180, depending on where this would end up. Now, 300 degrees would end up like somewhere right here. That would be what this graph looked like because it would go all the way around right there. Now our reference angle is going to be right here. So if we want to figure out what that reference angle is, we would take 360 minus 300, and that value would be 60 degrees. So that's kind of how we go about this. Now we're not going to be using graphs all the time. I'm just trying to use the graph just because it makes more sense when you use the graph. So this reference angle for 300 degrees is 60 degrees. So we're going to go back to, and it's tangent of 60 degrees. So we're going to go back to our table of all of our values here and go to 60 degrees and then go all the way over here to tangent. So it's square root of 3 or radical 3. So radical 3 is our value, but it's not the exact value because now we need to go back and use 300 degrees and decide what quadrant it is in. So 300 degrees would be in quadrant 4. So it would be somewhere like this. Let me get red. All right, so it would start here and go all the way around and be like right there. So that's in quadrant 4. So we need to determine is tangent in quadrant 4 positive or negative? And here it would be negative. So this needs to be a negative radical 3, and that's our answer. So it's that simple, but it takes a little bit of thought to try to figure out your reference angle, and then figure out your what sign you'll use. So I'll do another one, and then we'll look at some radical problems too. But those aren't too bad. So number 7, we've got cosine of 225. So we want to know what this reference angle would be here. So we're going to use, or I would use 180 here. I would say 225 minus 180. Because if we were to graph this, that's what the reference angle would be, or what part of the x-axis we would use. And so that's going to give us, what, 45? So our reference angle here is 45 degrees. Now we're going to go back. We're going to use cosine of 45 and figure out what value that is in our table here. So cosine of 45. So 45 over to cosine is square root of 2 over 2. So that's what value we're going to use. Then we'll need to figure out the sine. So square root of 2 over 2. Now the sine is going to depend on where 225 is, what quadrant it's in. So it would be in quadrant 3, because if we were to graph this, or we were to sketch this, we would have an initial side. It would go all the way over to like right here, because it's somewhere in between 180 and 270, so that falls in quadrant 3. So 225 is in quadrant 3. Now, is cosine positive or negative in quadrant 3? And here we have that it is negative. So this should be a negative number. So this is going to be negative square root of 2 over 2 as our answer. So that's all you have to do for these. Now, the hard part for some people is finding the reference angle. But like I said, you're only going to be using either 0 or you're going to be using 360 or 180. So it all just depends on what values it's in between. All right, so let's go look at radian problems. Now, these are when you're given your angle measure in radians, but it's not too bad to do this, because we can just figure out what this would be in degrees, and then we can use our same. To me, that's easier because degrees is not so obvious with some of these, but we're going to use. I'm going to show you to do it this way, and then I'll show you the other way you could do it too, and I guess I'll let you pick. But first, we're going to start off by taking this 11 pi over 6 and turning it into degrees. So we want to convert that to degrees. So if you remember, when we're converting to degrees, we multiply this by 180 over pi, because then that allows us to get rid of this pi, and we'll have 11 times 180, which is 1,980, divided by 6, which is going to give us 330 degrees. So this is the same thing as saying cosine of 330 degrees. So the reason I like changing it to degrees is because it helps me find my reference angle easier, because we need a reference angle for this. So if we were to graph this, it would look something like this. I'll just give you the sketch real quick just so you could see it. It would look something like this. We would have an initial side here. It would go all the way around to like right there. And then this would be 360 if it were to go all the way around. So we could say 360 minus 330, and that would give us 30 degrees. So our reference angle here is 30 degrees. Now, if you need to draw that for yourself, do it. I think you'll probably get to a point where you don't have to draw that for yourself, but I'm going to do it just so you can see where I'm coming up with that. All right, so 30 degrees is our reference angle. So we're going to look at cosine of 30 degrees and get that actual value, and then we'll decide the sine. So let's see, it was 30 degrees and it was cosine. So that gives us square root of 3 over 2. So this will be the square root of 3 over 2. And then that cosine of, we had 330 degrees, so we need to figure out where does 330 degrees go in our quadrants, and it would be in quadrant 4 because it would be somewhere in between 270 and 360. So it would be somewhere like this. Let me graph it. All right. It'd be somewhere like right there. So that's going to give us quadrant 4. So we need to know, is cosine, is it positive or negative in quadrant 4? And it would be positive. So that's right here. So it would be positive in quadrant 4. So the square root of 3, or the square root of 3 over 2 is our answer. Now, I guess the other way you could do this was, we know that, so I'll just show you this. I don't like doing it this way, but you can do it this way if you want. So we know that if we want to find our reference angle for 11 pi over 6, if we know that it is equal to 330, we could take that and we could say 2 pi minus that 11 pi over 6 will give us a number. Then we could determine where that number was, like in our quadrants, or that would be our reference angle. So we would use cosine of whatever that is. So I'm assuming it would be cosine of pi over 6. Our radians here would be pi over 6 for 30 degrees. So then that would give us pi over 3 over 2, or square root of 3 over 2. But the only difficult part is it wouldn't be so obvious where that was in our quadrants, because you don't know. I'm going to give you the unit circle to look back on, but I don't know, it just wouldn't be as obvious. So I like doing it the first way. Now we'll do more of these in class because the radians may be a little tricky, but it won't be too bad if you just convert them to degrees and then act like instead of 11 pi over 6, you had 330 degrees, and then go about your problem the same way as we did all of these. But all of these are going to be pretty straightforward too. We could make them a lot harder with like cosecant and giving you weird angles, but we're not going to do all that. So that will be it for this video.